This is a GPS module that I just bought recently, and these have become very inexpensive now, you know, which is largely because of the proliferation of GPS, not only in cars, you know, so the price of GPS units in for sat-nav in cars has obviously gone down hugely as the volume has increased, but also, you know, mobile phones. Every mobile phone, every smartphone at least now has a GPS chip in it, and so the price has really fallen through the floor, and these kind of things are very cheap to buy. So this has got a module on from a company called M-Blocks, and they're very famous for making these modules, and this one here, the Neo-6M, has been sold in huge numbers, and you'll find them all over eBay. So if you have a look here on the back, you can see RxTX grounds. This is obviously a serial output, so it wants to be connected to a serial port, and there, so you can see Neo-6M, again the name of the module. And so on here you've got the module, you've got that looks like a backup battery, there's a chip here which I imagine is probably a I2C ROM for storing a little bit of data. And you know, often you find these things are a low price, and you know, often these modules have been recycled from other equipment, so sometimes they're quite dirty and they're not really soldered on very well because they've been, you know, they've been hoiked out of other equipment and kind of soldered onto a new board so that they can be resold out of China. But you know, the result is quite nice, and you can afford to experiment with them. They're great. This one I got from a Chinese vendor, I can't remember which. This one has a little kind of short lead antenna with it also, so I don't really understand antenna construction, but you see this quite often. It's a little bit of ceramic at the end of the antenna, and this end's got like a little tiny coax connector which plugs onto a surface mount connector on the board. Let's see if I can plug that in. There we go. So there we go, that's quite nice, it's quite self-contained. So what I'm going to do is solder that header on so I can plug it into something, you know, maybe a Raspberry Pi, and write a little bit of code to drive the serial interface. And GPS units don't always work really well indoors, so we'll probably have to take it on a road trip to see what it's doing, but going to connect something up and look at some of the data that's coming out of the serial port on this low-cost GPS. Okay, so I'm outdoors now, and so I've got the Mac here that I'm going to be using for connecting to the GPS. Here's the GPS module with its antenna. I've just got it slightly out of shot here, so that because the antenna seems to work a bit better there. The Arduino isn't doing much, it's just a pass-through, so I'm just using that as an interface into the Mac. Now, first of all, I can show you on the Mac screen. If let's just have a look at the devices first of all. So there should be a TTY USB device. So USB serial A90739TP. That's the identifier of the GPS module. So first of all, I can run the screen utility, which is just like a TTY program that comes with the Mac, and it's common in Linux. So if we say dev TT, well, let's copy this rather than guess. So put the device name, and the speed is 9600 bits per second. So you can see if if we just connect serially to the GPS module, it's constantly spitting out all of these lines of text. Now these are called sentences. So the GPS module and other navigation equipment use a standard called NMEA. I can't remember what that stands for, but I can put it in the comments below. So in NMEA you see this kind of format. So right, if I break out of that, yeah, and I think I've got a grab here that I did earlier. No, that's not the right thing. Well, let's just have a look at screen again for a second. So you can see that all of these sentences start with $GP, so that's how it identifies different types of messages in the NMEA command set. And all the fields are comma separated, so there are a number of different values in each type of message, and each type of message has its own particular fields that it shows. And then at the end there you see a star and then a number, which is a checksum that you can use so that your program can use to check if the data is good. But rather than having the data pour up the screen like this, what I'm going to do is I'm going to use some Python scripts that I've already written myself, and I'll make these available on my GitHub site. But first of all, if we look at messages, if we look at this messages, now what this does is it's going to listen to that stream and it's going to identify what type of messages are available from this GPS unit. So this is just going to listen for a few seconds. And there we go. So we've identified several different types of messages. There's different sentences. So as I said, they all start with $GP. So we've got RMC, GSA, GLL, VTG, GGA and GSV. Now I'm going to look in particular at the GSA, which is interesting because it shows you what satellites are visible in the sky at the moment. And we'll also look at GGA, which you can get various bits of information out of, including the time and of course the GPS fix. So another script that I've got here, if we look at time, for example, so time GGA. So what this is doing is it's listening for those GGA messages and it's extracting the time, because GPS location works on a very precise measurement of time from 4 or more satellites, and so a GPS module is an excellent source of correct time. So that's one thing that we can do. And if I just show you what that looks like in the the time GGA. So basically what I'm doing here, the scripts all have very similar formats, so if you follow one you should be able to make sense of them all. So I'm opening that TTY device that you saw, that represents the actual GPS module, making a serial connection to that device, and then we go into this loop, and so we're reading lines of text from that stream, converting into ASCII using this decode function, and then we call this function NMEA, which is this thing up here. And you'll see if you look at the different scripts, we have different each script is looking for a particular different sequence, but the ideas are common. So we're splitting by commas, so we get all the different fields. We're checking for in this case GGA, so $GP GGA, and when we see one of those messages we're going to call this print time. And what print time is doing is just extracting field number 1. So field 0 is actually the GPGGA itself, but field 1 is the time. So having matched the time, we're pulling out the hours, minutes and seconds, and then we're printing that out on the screen. So that's how that one works and how we get an accurate time. We can also look at location. So if we look at the location script here, which also uses those GGA parameters. So you see that's printing out the location. So in this case, if we look, so we've got the actual line itself that's coming out of the GPS is this $GPGGA here, and you can see there are various fields, and in fact the time is the first field there, that 133, so 13:30 and 25 seconds. And then we've got longitude, latitude, elevation is there as well. And so what my program is doing is extracting those bits of information. So let me just I'll just take out the clutter at the moment. So where am I printing it out? Oh yeah, right. So let's just take out the actual string itself, because we're not so interested in the format of the NMEA message. And there you see, so under location there we have 51 north, 0 west. The height above sea level doesn't seem to be reading back. That's probably a problem in my script. But we also see number of satellites equals 6. So in actual fact, to get a GPS fix, you need to have at least 4 satellites in view. So it does some very clever calculations using geometry to work out your location on the Earth, and also your elevation above the Earth's surface. So you need at least 4 satellites to get a fix, but this particular module can read as many as 12, and then you get increased precision of measurement. So we can look at the satellites as well. So if we have a look at my satellite script here, satellites GSV. So this one is looking for the GSV message, which contains information about the satellites. So you can see there's a lot of information coming out about the satellites that are available. And if we have a look at one of these, for example, let's take that one here. It's a little bit difficult to read. But we've got total segments 3. What that means is there's going to be 3 messages that contain all the information about the satellites, because if you have all 12 satellites available, then there's not enough information in one NMEA message for it to all fit into one, so it splits it across 1, 2 or 3. So you'll see here we've got total segments 3, segment 1, segment 2 and segment 3 in different messages. And I can make it a bit clearer to explain what's in that message. Let's I'm looking in the wrong script. Satellites, okay. Oh yeah. So we'll make it a little bit easier to read like that. Okay, so it's formatted it with some spaces in. But if we look at this one, for example, so this is one of the segment messages. So this is segment 3. this one, so the total number of satellites that the GPS can see at the moment is 11. So it's split those across 3 segments, and this is the final segment here. So under sat unit we've got sorry, I just lost it there, but satellite, oh there we go. So under sat unit we've got 3 sections. So that's section 1, that's section 2. So this represents the 3 of the satellites that can be seen. And so we have PRN is actually a unique identifier for the satellite, so in this case 24, and then we've got the elevation and azimuth, which are the position, represent the position in the sky for that particular satellite. We've got SNR, so SNR is signal to noise ratio, which is very important in radio technology. So this is saying something about the signal strength from this particular satellite. And then these extra fields here, sat name and launch date, I've actually added those myself, because from knowing that this is number 24, PRN 24, you can do a lookup in a table and you can find out what the name of that particular satellite is, and also the launch date. And if you look inside my script again, you'll see this section birds here is actually where I've put this information in. So depending on the index, so that's index 0, which is a dummy. So PRN 1, index 1 here, we can see is USA 232, and that was launched in 2011. So I'm just using that simple lookup table to make the output a little bit more interesting. Yeah, so so that's it basically. I mean, just using those 2 particular sequences, the GSV and GGA, you can get a lot of information about what satellites are available, and the time and the fix and so on. There were also some well, let's just run it again. Let's run messages again to see what message types we've got available here. So we've got several different types of message, like VTG for example. So I won't go into it in detail, but I wrote a script for VTG also to extract the goodness out of the VTG message. There's some debugging here, but you can see here this is one of the decode messages. So so for some reason the speed hasn't filled in this. Could be an error in my script, but this allows you to see in terms of course and speed. So course is the angle that you're heading in, and speed is obviously the speed that you're going in that particular direction. So that's obviously a really useful type of NMEA sentence if you're in a vehicle of some kind and you want to interpret what's what your course and speed is. So I wrote a number of little scripts here. So there's one for RMC, there's one for GLL, and I won't explain those here, but I'll upload all of these to my GitHub site, and if you want to experiment with them yourself, then you're obviously very welcome to do so. So I hope that's given you a clue about what you can do with these very cheap, with these £3 GPS modules, which are a really astonishing value for the kind of thing that you can do with them.